Now today, I'm showing you how to do what we've been doing since day 2, but with radians. Radians are just another way of solving the exact same thing that you've already been accustomed to solving. So if I asked you, what is cosine of pi over 6? I'm asking you the exact same thing as what is the cosine of 30 degrees. It's the same thing, just it sounds different. But truthfully, radians is much easier process than degrees. Because with degrees, if you're in quadrant 4, I said, what is the cosine value of 300 degrees? You got to figure out, okay, well, what's the reference angle? That would be 60 degrees. So we have to use the 60-degree column of our trig chart, okay? I want to show you in just a little bit after we get finished with page 1 why radians is actually much easier than degrees. Now, I'm not going to write any degree angles down because I don't want to junk up this page. I mainly want it to be filled with our radians for today, but I do want to give you a reminder that right here is 0 degrees. Right here is how many degrees? 30. How many's here? Good. And here? Good. And here? 90. Okay, now hang on. Even if you don't know what this angle is, do you remember what you can add to get from here to here? 30. Good. So 90 plus 30 is 120. And even if you don't know what this angle is, do you remember what you can add to get there? 15. So 120 plus 15 is 135. 135 plus 15 is 150. And 150 plus 30 is 180. Good. So even if you don't have all these angles memorized, but you know how to get from one angle to the next, you can then fill out the rest. Okay? With radians, there's a similar pattern. Now, this is where you're going to start writing, but look what I'm going to do. I'm going to give you a pattern for radians. Do 6, 4, 3. Now, what I'm about to do, I'm skipping quadrant angles. Don't worry about quadrant angles. So we start 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. So starting in quadrant 1, 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Remember that. That might be the hardest part of memorizing the radians. 6, 4, 3, 3, 4, 6. 6, 4, 3, 3, 4, 6. Now, in quadrant 1, all of your numerators are going to be the same. They're all going to be pi. Every single one of them. Now, here's how you remember the numerators for quadrant 2. I'm going to write down a little cheat. That stands for denominator minus 1. So this numerator must be 2. This one, 3, and this one, 5. Now just give them a pi in the numerator. Six, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. And then just remember, in quadrant 2, as long as you know the denominator, you can find the numerator by subtracting 1. I'm going to let you do this quadrant by yourself once I give you the pattern. In quadrant 3, it's denominator plus 1. Fill in the numerators for me, please. That's it. Yeah. Just remember, quadrant 3, okay, denominator plus 1. Now over in quadrant 4, this is the pattern. Twice the denominator minus 1. Twice the denominator minus 1. Did you get them? 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6, and then just remember, denominator minus 1, denominator plus 1, twice the denominator minus 1, and you'll have all the radians of the unit circle memorized, which I think is going to be way easier than actually memorizing the angles or having to remember the pattern and then add. Okay? That's actually very, very predictable, the pattern here. Now, let me show you what your quadrant angles are. Here, your quadrant angle is 0 degrees, or sorry, 0 radians. We're doing radians now. Here, we're at pi over 2 radians. Here, we're at pi radians. Here, 3 pi over 2. And then if you make one full rotation, you're at 2 pi radians. Now, if you want a pattern to memorize that, here's what you can think of. Let's think of these quadrant angles as 4 slices of a pie. Here's a slice, 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 all right? Well, if this is pi, then this must be half of pi, pi over 2. Here are 2 slices of the pie. 2 pi over 2 reduces the pi. Here we have 3 slices of the pie, so 3 pi over 2. And here we have 4 slices of the pie. And 4 over 2 reduces to 2 pi. So that's one way of thinking about it. Or just memorize pi over 2, pi, 3 pi over 2, 2 pi. Do you know, if I were to ask you, I'm going to use a quadrant angle. If I were to ask you, what is sine of pi over 2? Do you know what your answer is going to be? What about sine of 90 degrees? You know what sine of 90 degrees is? 1. Very good. So what's sine of pi over 2? Very good. Yeah, it's the same thing. Your special angles, your special values did not change. This is still root 3 over 2, comma 1/2, with a tangency of root 3 over 3. This is still root 2 over 2. For your cosine and sine with the tangency of 1, and this is still 1/2 root 3 over 2, and then root 3. Now, I'm not going to write the rest of the values because they're going to be the exact same. Just remember, the signs will change. And that's where all students take calculus comes in handy. You can then remember which of these values should be positive based on what quadrant they're in. Okay, move over to side 2 whenever you have side 1 done, which we should by now. All right, what they want you to do here is they want you to find the measure of the reference angle for each given angle. If they say pi over 4, for example, then the reference angle is pi over 4. If we had to find cosine of pi over 4, we would know, okay, we're going to use the pi over 4 column. Okay. Here, pi over 6, the reference angle for pi over 6 is pi over 6. If they were to ask you find sine of pi over 6, you would use the pi over 6 column. Now, theta of negative 5 pi over 4. The reference angle for that is pi over 4. Here, 5 pi over 4. The reference angle for that is pi over 4. So if they were to ask you, find tangent of 5 pi over 4, here's how you'd go about solving that. You would realize, oh, well, the numerator is 1 greater than the denominator. So we must be in quadrant 3. The reference angle for pi over 4 is pi over 4, so we would be using the pi over 4 column. This is where radians becomes much easier. If they give you a radian, it's easy to identify what column you're supposed to use without doing hardly any thinking at all. The reference angle for 5 pi over 3 is pi over 3. The reference angle for 7 pi over 6 is pi over 6. You see the pattern here? You take away the number in the numerator and you keep what? the denominator. Good. That's exactly the pattern. So if I were to tell you, what's the reference angle for 2 pi over 3? What is it? Pi over 3. Okay, what about 7 pi over 6? Good. What about 5 pi over 4? Yeah, you know now exactly what column you have to use by doing what you just did. Much easier than degrees. Okay, now that we have that, let's move over to side 3. Now I will keep this on my board here so that you don't have to keep flipping back and forth through your notes. Sine of pi over 4. Notice in the numerator, there is only pi, so therefore we must be in quadrant 1. All things are positive in quadrant 1. So I'm going to go ahead and put a positive. Pi over 4 column, locate the sine value. Our answer is root 2 over 2. Cosine pi over 3, still in quadrant 1, where all things are positive. So let me put a positive here. Pi over 3 column, locate cosine, positive 1/2. Let's skip that one. Okay, now let's look at sine of 2 pi over 3. Notice the numerator is 1 less than the denominator. So we must be in quadrant 2, where only sine is positive. It wants sine, so I'm going to put positive. And if we had to find 2 pi over 3, what column are we using? Pi over 3 column. Good. Pi over 3 column. Locate the sine value, root 3 over 2. Nope, I don't want to do that one. Okay, tangent of negative pi over 4. Pretend I have a unit circle here. Here we're at 0 radians. If I rotate negative pi over 4, I'm here. Negative rotations are just that. It just tells you which way to rotate. Now I'm in quadrant 4. The only thing positive in quadrant 4 is cosine. Cosine is positive. They want tangent though, so I'm going to go ahead and put negative. Pi over 4 column, locate the tangent value. Your answer is -1. I'm going to let you practice some. I want you to do cosine of pi over 3, tangent of 5 pi over 4, sine of 11 pi over 6. Try those. Let's see how we did, everybody. Okay, let's start with 2 pi over 3. Notice the numerator is 1 less than the denominator. So we were over here in quadrant 2, where only sine is positive. Since they want cosine, I'm going to go ahead and write negative. 2 pi over 3 means let's use the pi over 3 column. And now locate the cosine value. Your answer is -1/2. Tangent of 5 pi over 4. Notice the numerator is 1 greater than the denominator. So we must be in quadrant 3, where only tangent is positive. It wants tangent, so I know my answer is going to be positive. 5 pi over 4 means let's use the pi over 4 column. Locate the tangent value, +1. Last sine of 11 pi over 6. Notice the numerator is twice the denominator, -1. So we must be in quadrant 4, where only cosine is positive, but it wants sine, so I'm going to put negative. 11 pi over 6 means let's use the pi over 6 column. Locate the cosine value, -√3 over 2. Yes? No? Maybe so? These are all your quadrant angles here, everybody. Not on the trig chart. 3 pi over 2 is here. The cosine value of 3 pi over 2 is 0. Pi is right here. The tangent value at pi is 0. Sine of pi is still here. And the sine value of pi is 0. All those happen to be 0. All right. Yeah, what's up?
What is sine 11 pi over 6?
It could be. I might have made a mistake. Which one are we at?
The last one that you circled.
This one here?
Yeah.
Yes, sine 11 pi over 6, pi over 6 sine. Yeah, I accidentally wrote down the wrong thing. Good catch. -1/2. Who was that, Brooke? Bonus points on your quiz. Well done. Yeah, I accidentally wrote down the wrong figure, guys. Thank you so much. Did y'all get -1/2, most of y'all? Good. Y'all did it right. I did not in that case. All right, let's move over to side 3. Now, they want us to, for example, 3, they want us to convert from either radians to degrees or from degrees to radians, and then they've given you a formula, if you will, on how to do that. And that most likely will not be provided on any test in the future. Now, what's really nice about 135 degrees is 135 degrees is one of our special angles. So if you have the unit circle memorized and you're able to place all of your special angles and all of your special radians, you could just go look at that unit circle and realize, oh, the answer is 3 pi over 4. 135 degrees and 3 pi over 4 radians is the exact same thing. But if you don't have that memorized and you know how to convert from one to the other, here's what you would do. Take the angle it gives you, 135. If it's in degrees, you multiply by pi over 180. Now, if you multiply numerator times numerator, this is where we're at, and now denominator times denominator. Now, if you leave your answer like that, it's obviously wrong. We would have to reduce. And no, you're not allowed to use graphing calculators during this unit, but you are all allowed one of these. So if you could at least recognize that, well, both of these numbers are divisible by 5, so let's do that. 135 divided by 5 is 27. 180 divided by 5 is 36. And then now you might be able to recognize, now that the numbers are a little bit more manageable, that both of those numbers are divisible by 9. 3 pi. For the next example, they give us a radian. 7 pi over 10. 7 pi over 10 is not in our unit circle. So you would have to know how to convert it from radians to degrees. If they give you a radian, you're going to multiply it by the opposite of what we just did. 180 over pi. Now, what I'm about to do to simplify this problem is called cross canceling. These pi's cross cancel. 10 and 180 also cross cancel. 10 goes into itself once. It goes into 180 18 times. The only thing I'm now left with is 7 times 18. 7 times 18. Our answer is 126 degrees. As long as you're good with the trig chart, you know how to find cosine of 3 pi over 2 and all that kind of stuff. This might be the most difficult stuff of this unit, what we're doing right now. Let's see here. Draw the following angles in standard position. Make sure to show the direction of rotation. No, don't worry about that. I think your Delta Math is going to do a pretty good job at going over that with you today. And it's pretty much a continuation of what we did last class, except now they're dealing with radians. When you get to that part on Delta Math, if you need help, let me know. Here, to find coterminal angles. Now, I think it was day 1. Day one, we learned how to find coterminal angles if you're dealing with degrees. So if I wanted to find the coterminal of 30 degrees, what do I need to add to that? Remember? 360 degrees, yeah. That's how you find a coterminal if you're dealing with degrees. You either add or subtract 360. Well, today we were learning about radians. So if they give you a radian and they say find the positive or negative coterminal, you have to add or subtract 2 pi. All right, move over to the last side of our notes. What we're about to do might be the most challenging part of our lesson today because you have to add and subtract fractions. All right, here's what I like to do. If it says we're giving you the angle pi over 4, find a positive and negative coterminal. Well, I'm going to have to add 2 pi. When I have a fraction that I'm adding with a whole number, I like to put that whole number over 1. This is one way of doing adding or subtracting fractions. I'm going to do butterfly method in a way. I'm going to multiply this way. Pi times 1 is pi. I'm going to notice the sign here. And now 4 times 2 pi is 8 pi. Now multiply your denominators. 4 times 1 is 4. And then just simplify the numerator. Pi plus 8 pi is 9 pi over 4. And then if you do it the way that I just did it here, here's how you find the negative coterminal. Now do pi minus 8 pi over 4. Simplify the numerator. Pi minus 8 pi is negative 7 pi over 4. Let's try it one more. Let's do 11 pi over 6. Okay, I'm going to take 11 pi over 6. And I'm going to add 2 pi over 1. Very good. Very good. See a lot of pencils writing. This is a good sign. All right, for my positive coterminal, here's what I did. 11 pi times 1. 6 times 2 pi. All over 6 times 1 is 6. Add your numerators, we get 23 pi over 6. Now let me copy down my work, except now subtract. If you simplify those numerators, you get negative pi over 6. That's how you find your positive and coterminals if it's in radians. We are on unit 3, day 3. Submit your notes on my Canvas page. And then clear your desks of everything. We'll start the quiz in just a moment.